Well, hello, dear listeners. Thank you so much for joining in again. In today's episode, we discuss about the genesis of us at Big Blue, me and Sean. We talk about open banking. We talk about PubSub, NATS, and the role it played at banks like Citibank, the role it played at manufacturing firms and at healthcare facilities at NHS. We also explore the roots of Sean's childhood at Luton, and we learn about how fascination about computers that started at the school classroom on a day when teacher rolled in a box, that fascination paved the way all the way for him to come into the world of computers and internet and technology. We also understand the big bets that Sean has for the next 100 years and how Expanso is aligning itself to meet the ever growing demand of using data to power the data driven decision making. And that all at the edge. So it's all at the edge of the seat stuff. Let's join in.
Feel I have stood on the shoulders of IBM, if I may say, because suppose in sectors like banking or healthcare and those places, that's where trust is very essential. I say bank is not a four-letter word; it's a five-letter word. It begins with T, ends with T. It's trust.
Yes,
If I
yes,
trust, if you have a dollar bill, it's written say Government of England or Government of India. We know
mhm,
that if I give you this, you will give me £10 or $10
perfect.
something
Yeah,
because you
exactly
trust
right.
something. So that's where the blockchain comes. So if we can decentralize trust, whosoever
Mhm,
you can trust, if Sean gives me a paper saying that Sean will
mhm,
give me 100, say a pound,
yeah,
and if you will keep your promises, that's enough for me. I don't need someone third party to guarantee me. In the
yeah,
same way, this IBM has helped me build
mhm,
this trust with people like you,
mhm,
Naira, people from Korea, people from America. So
exactly.
once the trust is there, I
Mhm.
feel people are not so guarded. That's when the conversation
Yeah,
flows. Once the
absolutely.
conversation flows, that's when the good conversation comes.
That's the good stuff right there. Yeah,
Yeah.
absolutely, absolutely.
So IBM helped me, being blue, helped me get
Mm,
that trust so that I
mhm.
don't have to meet you 10 times so that you will observe me, so then I'll observe you. Oh,
Just
that's what
keeping an eye
Naval
on.
is. Yeah. That
Yeah.
helps me. I always use that.
Mm.
So
No,
I
quite right.
felt very fortunate that that's the better part of working in working in a global role, working in a team which is so open, uh, and
This is
trust takes time. Yeah, sorry.
this is the thing. It's one of those things that's really important. It's hard to build. There was an ethos at AWS which one of the leadership principles is earn trust.
Yeah,
Because trust takes forever to build, but it can be
yeah,
broken in a second. So
yes,
we all work very, very hard to be dependable, reliable, to deliver great stuff for people.
yeah,
And we also, in doing that, we learn to trust other people as well. We build up a
yeah,
network of people that we want to speak to, spend time with, work with. I mean, you'll have one, I have one. We have a list of people that if we,
yeah,
want to build something, we want to share something, we want to like shoot an idea of someone, we
yeah,
go through that list and we go, oh, okay, I'm going to talk to these people because
yeah,
from your experience, having worked together, having spent time
yeah,
together, that you can trust them to be a
yeah,
dependable, reliable input and force in that direction.
exactly.
And that's so rare and it's so valuable. And it's something we work
Yeah,
really hard to maintain
yeah.
in what we do.
Yeah, and I have seen the folks, a lot of people who have come from a humble background, when they see education as a means of getting an employment and
Hmm.
getting wealthy,
Hmm.
they, and I've come from a very humble background, to be very honest with you. And for
Hmm.
me, getting a degree or getting a post graduation degree, doing an engineering or doing this was a way for me to afford, put some food on the table for my provide for my family and stuff,
Exactly. Yeah.
and get if I get a good salary, it's a bonus. Otherwise, just provide for my
Yeah.
family. Education was a way for
Hmm.
reach them.
Hmm.
When I came to larger cities like in India, Mumbai or
Yeah.
Bangalore, I think the same thing is there. There will be rural places in England as well. Then people will come to London, which is like
Hmm.
bigger places. Uh,
London, Manchester, Cardiff.
yes,
Yeah.
definitely.
Yeah.
And we know all these places because all the Indian cricketers play county cricket. So we know that
Right.
Sachin
Okay.
plays there. So he
Excellent.
plays at Cardiff. He plays at Lancashire. He plays at
Mhm.
Gloucester. Plus, I've been
Yeah.
an EPL fan, so I'll not tell the team I support because then the conversation will end immediately. Someone will press a red button.
Hey,
But
judge not lest ye be judged. Like I'm no judgment from me, Naval.
so I guess there's a proverb in England that if you don't love Leeds, Leeds United, then you can't love anyone else. So so a lot of people you start with loving Leeds, and then you can go to Manchester United or Chelsea or
you work up from there.
yeah. So I love Leeds. They have come back and they had some amazing season. So
Nice.
why I talked about coming up and the relationship with trust is because when I came to Mumbai and larger cities, I saw that people who have just passed matriculation, who are not highly qualified, and they are in sales. Often you will find that folks who are the salespeople in business development, they are the richest folks driving the most expensive vehicle. Why? And they may not be the highly qualified, most polished, because clients eat out of their hands, their palms. Why? They trust them. They trust me. So if you are a billionaire and you trust me, I could be as good as a high school dropout. And the other guy could be an Oxford BTech computer science gold medalist, and that guy would be working as a developer relationship head. I'll be working as a sales guy. I'll be making £1 million a year. And that kid who has come from rural, that kid has slogged his backsides off to get an Oxford or Cambridge degree. He'd be scratching his thinking, this rural buffoon makes more money. Why? Because you trust me.
This is the thing, like, I think we live in a world these days where hard work and relationships are what drive things forward.
Yeah.
Like I too saw education as a way to get ahead a little bit and be able to provide. But fortunately, the thing that I was very interested in from an early age was computing. I remember the first time I saw a computer, I was in my second year of school. So this has been like 1996, 1997. And it was an Acorn PC, a British PC made in Cambridge.
Yeah.
And my teacher, she rolled in this big box on a trolley into the classroom, right? And we were all like, what is this? She goes, class, this is a computer. And she asked the most incredible question I've ever been asked in my life. She goes, what do you want to make? And we're like, what do you mean? She goes, we can make anything with this. This is a computer. We're like, it was Christmas time, so we're at that same time of year now.
Yeah.
And we all went, Santa Claus, let's make Santa Claus. And so she goes, okay, and she fires up the print program, the paint program, draws Santa Claus, and I can still remember the image to this day of what it looked like. And she goes, there we go, we've made Santa, but watch this. And she pushed a button, and it started printing out onto a piece of paper.
Wow.
And so we had, we started with this box on a trolley, and then we made something inside the computer, and then we made that real in the world on paper with the push of a button. And to me, it was like, my God, this is a magic box. It could do anything. And that's a thought that's never left my mind ever since then,
Yeah.
So I think people that experiment and explore, not everyone has the good fortune to go to a good school or to be in a part of the world where education is available. But computers are pervasive. And I think if you can spend your time and get access to these things and tinker with them and explore, someone will find what you're doing valuable. Someone will find it interesting. And if it's a passion that lives within you, then you are destined to make great things because it's what you care about. You care about building and sharing and learning and, being part of the community. And I think that's the core of it as well. Community and trust are hand in hand. We have that group of people. We build these relationships with people in different spaces. You're currently in your home you're currently in India, right?
In Mumbai. Yeah, in India.
You're in Mumbai. I'm sitting in Wales, so we are like 6,000 miles apart. And yet that community, even though it's separated by distance, is still there across borders, across the world, across time zones, by trust, by experience, by by having done this stuff together in the past. And it's just a phenomenal world that we live in, so connected. I think COVID really pushed that forward too, because we had our little enclaves inside the office. There was the team you worked with that you saw every day, and that was your group. And then there may have been like the people in the satellite offices, maybe like Hersley at IBM or Glasgow, all these kind of places. So they were extended beyond that. You'd see them less frequently, but they were still there. But beyond that, you were still stuck to your regionality. And then COVID comes along, and all of a sudden, the world shuts down, but simultaneously, it opens up. Because now everyone is a Google Meet link away or a Teams Meet link away. And it takes, we agreed this on email.
Yes.
We sent a couple messages back and forth, and now we're speaking about all these cool, wonderful things. And that is something that, I think we take it for granted sometimes. You see these return to office stuff going on, like Overexpand. So we're a distributed computing company.
Of course.
But with distributed computing, we also have a distributed team. We're in Seattle, we're in Los Angeles, we're in London, we're in Germany, Libya, we're everywhere because that ethos matters to it. And I think this return to
Maybe
office,
sometime in Mumbai as well with
we
a
we are currently looking at people in India and making relationships there. We'll be in touch, but yeah, like it's a big
just
world,
kidding.
and I'm not, but it's a
Yeah,
big world, and there are great people everywhere, and we work really hard
I'm
to find them.
interested. I'm
Yeah.
interested. Yeah, and the best part here is, to be honest, is that um, yeah, definitely the community and standing, and that IBM allowed us to use that platform, and our managers kind of build that kind of culture where they could. There were Slack channels where you could crib, and we knew that the manager is looking at us. Hey, Jonathan, don't look at us. We're just about to crib about what just happened there. Oh man.
Oh, dear me.
So then that gave me the courage, to be honest, because a lot of people, even people who live close by, who we meet very frequently, we don't know if you're stepping on the wrong foot or something, and they may never. And it's very easy for you to just block me or not reply. That's the reason, because I had fortune to spend time with Naira and others in Dubai. I had met them and the entire team and worked with them for some time. So I knew that I could count on her, and she would not. She would give me some reason to say no. She wouldn't.
Yeah,
That's the reason I said, let me reach out to a gentleman called Sean. I know you from a long time at IBM. So that's the reason, because you shouldn't feel that why out of the blue. I said, let me leverage IBM. Of course, I can't travel to Australia and Korea and Japan, and God willing, someday I will be. But I know most of them. I am in touch with them through electronic means.
Yeah.
That was the cold open. Now I start the boring stuff.
Let's do it.
So as most of the so dear listeners, as you know, I'm the culprit of doing some very cool cold opens. You just saw what I did there, but that's how I think the most interesting conversations work. So listeners, I always believe that there's ton of, like everyone is doing podcasts, that there's a lot of text to speech software, so a lot of stuff can be written by ChatGPT and spoken in a human voice. Now Google has a notebook LM and everything else. If something is made by a machine, it goes to machine, it gets read by machine, processed by machine, it's for machine. It's a bit like democracy. By the people, for the people, of the people. So if it is written by a human, spoken by a human, with all the fragilities of a human, then that, because it's spoken from heart, whether broken with not so perfect audio or something, it reaches human heart, because you know that there are two actual dudes hanging out and people speaking, right? It's not a machine speaking in a monotonous voice. That's the reason. And humans love to eavesdrop. So if we are natural, they would want to know, how does Naval actually speak? What is Naval's actual take, or what's Sean's actual take on what Expanso does? Not his like canned response, like speak to manager, speak to HR, not that one. So yeah, so dear listeners, thank you so much for tuning in again this week. Of course, this will come out later. We are shooting it on a nice sunny Sunday at Cardiff with a gentleman who I'll be introducing sometime sooner. Those who are joining me on Spotify, it would be so cool if you can join us on the Spotify's video stream. Those who are joining us on audio stream, I know you folks put in a lot of comments like, though you are abandoning me, stay on audio is kings. Yeah, I'll always be there for your audio. It's just converting an MP4 to MP3 and or OGG Vorbis to the lossless format, and I'll always be there for you. So those who are there for Apple Podcasts and Spotify, my old time listeners, I'll always be there for you. It's coming always on audio format, but I have added a couple of video format as well, because it's kind of builds trust. Most of us record on Zoom and Teams. If there are some people who say, no, don't get my video, I said, that's fine. But Sean is cool, so we are doing a video. So you can feel free to turn on the video. For others, I'll introduce him. Something that Sean has put a gun on my head and asked me to say. So Sean is the head of, no, he hasn't, he's a nice guy. So Sean is the head of developer relations, DevRel, as we used to say in IBM, and developer relations at Expanso. The creators and maintainers of Sean, Q for you.
Bacalhau.
Something. A distributed workload orchestrator. So when you folks hear distributed, and you hear workload, and then you hear orchestrator, some bulbs go out, some bulbs just light up. Something like Kubernetes, something like maintaining all those clusters and all those stuff. So we'll figure those stuff out, and I will play along with the listeners, and we'll ask some questions to Sean. So this workload orchestrator enables all of us to take our workloads directly to data. And Sean has been so kind to make an amazing website. I will pitch that website to you, because that shows his entire journey, and that also shows that you can put some glittery stuff and people will like it. So if you go to smt.codes, those who are listening to me on audio, you will find that the moment you click on project, some glittery stuff goes up. That's so cool. A lot of us limit ourselves to LinkedIn and maybe a GitHub page, but a middle page, because one gentleman who made a big blue company said that good design is good business. Design always stitches tech with human. So as I know, I'll let guest introduce himself as well, but before we get his words in, I'll just break it down how the understanding of any process and design comes together. So GitHub is hardcore tech. You can see like all the deep greens, and then that Sean has been working really hard on. So you can see how active he is. And then LinkedIn is there for the boring stuff, where all the business and lots of money making people go there, and then there's a lot of conversation that happens there. But between these two, there's a beautiful website that you can design. You can use any tools that you want to. I use Notion. Notion has a good Notion site. This is not sponsored by Notion. They can give me some money if they want to, but they have an amazing site. I put like all the Notion stuff there. I put like all the Kanban boards there of what I'm working on. People can actually see those tasks and what are in progress, so that they will not call me. That's another reason for me to always keep the lights off and work silently with my hoodie on, and don't bother me. Just look at there on the side. But that's an amazing place that you can go and have a look. Second is, when we talk about design and good business, any process that any, say, HR process or a finance process or a marketing process or a sales process, any organization works on these functions. These functions have processes like hire to retire, procure to pay. These processes are under the APQC framework, are broken down into sub-processes. Every sub-process have an activity. Every activity has tasks. So when you finish a task, then activity gets completed. Then the sub-process goes. So if you want to hire someone, so you first to go out and ask the manager, why do you want to hire someone? He said, no, there's a lot of work we cannot do. Why you cannot do? Skills required. People are overworked. Okay. Go to finance. Ask for money. How much money you're going to pay? Go to market. Ask the money. How much money is an average guy paid? Okay. Get the finance approval. Get a headcount approved. Then understand if it's compliant with the diversity guidelines and all the guidelines. And then, okay, so the point of what I'm trying to say is that before you, it's very easy for someone to, for a management consultant to say, hire to retire. But inside the hire to retire, we have talked about getting money, getting approvals, getting compliances, getting all the risks checked, then getting allocating then which country and why. And then you come to the hiring manager and say, okay, now give me a job description. Then the job description gets vetted. Why, which technology? Is it too biased towards particular, or is it too not biased? What kind of roles? Why do you require those roles? Is it a true blue, a white collar, new collar, blue collar? All those collars will come into picture. Then you just set up the job description. Then you decide on the careers portal, on LinkedIn, or whichever KRB brass rings or whatever, wherever you want to. So that's how the process starts. Why I talk about design is because whenever a process or the final distribution of any process is a task, this task either gets done by a human or a machine. If a human does it, you want skills. Machines also have skills. On those skills, like it's done by an algorithm, then you understand how you can figure out DevOps. That's where the feedback comes. The machine learns, the AI learns, and then it keeps on improving. You figure out to train, test, and again improve machine. In the same way, you have manager communication for the employee. That how can the employee do better? So that's how the humans work. So distribute task, process activity task, which task by human, boring repetitive stuff, check to machine. Machine will do it. Creative, nice stuff, meeting people, getting trust, establishing relationship, buying, getting an executive buy-in, getting sponsor buy-in, getting funds allocated. That's where humans come. They want to see your flesh and blood. That's where they cannot trust an AI algorithm. It's not a B2C company that you're not selling a shampoo or a soap. You are selling technology. So you need people to come and sit. Even then, there's miscommunication. People feel, what will happen if something goes out? Oh my God, what if you get a good offer and you change the job? Who will handle this project? lot of stuffs happen. So point is trust technology, and that's where design comes into picture. Design stitches it all together, and it ensures that the entire tech is wrapped nicely around easy to consume manner to people at different levels. For all that long detour, I know we are going all the way to Newcastle and Leeds and Lancashire, but we'll come back. That's the reason. That detour is because it's so much that goes behind making simple tech. Is that this website is like a beautiful wrapper, because the gentleman in front of me has written books, has won prizes, but can he put that on LinkedIn? It'll get scrolled past. A post of LinkedIn of 6 months ago, you can't find. Even my Medium post that I used to write as developer advocate, they're now behind paywalls. I can't read my post. I can't search them. This is a beautiful collaboration. He has brought all things together. Very good curation. So curation in the modern world, it helps him to show his versatile nature, his pleasant personality that I know. And if you keep scrolling, you'll find him getting a hat. So he has put like some, Easter eggs everywhere. So he feeds to everyone. So why I'm saying this? What's the purpose of the podcast? It's because bringing people who are doing amazing stuff, who are going a bit beyond the boring and ordinary, and then doing something curious. And I keep an eye on all these happenings. Oh, Easter egg. Oh, there's a guy in a hat. Oh my God. Let me pull this guy in. Let me see if he remembers this mug. Yeah, luckily he remembered this mug. And maybe he doesn't know that I have done that depth of research. We'll get back to the IoT and distributed computing and processing on the edge and bringing data to the AI or AI to the data, reducing latency, IoT. We'll go all in. We'll go into the Substack of his posts, my comments, and everything. SCADA and the evolution of electricity grid, and you name it. We can have this itself as a 10-part podcast series. But before that,
yes,
I will let the giggling gentleman introduce himself and then share a little bit about himself to our all listeners, and where he is, what he's doing, what are his likes, and then we'll kick off the podcast.
Well, I'm not sure I can top that introduction, Naval. That's the most generous description of me and my career I've had in quite some time. So I thank you for that. But yeah, for your listeners at home and at work and on their commutes and wherever they've chosen to sit down and take this in today, I thank you for the time and space. I'm Sean Tracy. As Naval said, I'm the head of developer relations, DevRel at Expanso. We're a startup based out of Seattle in the United States. And as Naval said, we work on distributed computing with an open source project called Bacalhau. And for everyone listening, Bacalhau is a Portuguese word. It means cod, because that's what we do, compute over data. And if you want to look it up, it's Bacalhau. And you can go to bacalhau.org to find out everything about that there. But for me, as Naval said, developer relations, I've been doing DevRel now for 7 or 8 years. Naval and I's journey together started at IBM a long time ago at the Big Blue. But I've had a surprisingly long and I think interesting career of making weird stuff, which people always seem to enjoy. And I've not had a reason to stop yet. I started off as a creative technologist in a town called Bournemouth, which is on the south coast of the UK. My job there was to try and imagine the future 5 years from now and build what we thought that future looked like with modern tech. And so back in like 2012, when we started that off, we noticed that speech to text was getting very interesting. It was getting quite good. Google and Microsoft were coming out with these APIs that you could send audio to and text would come back. And that hadn't really been done before. So we thought, okay, we can imagine a world where people would have computers that would listen to them and try and understand what's going on there and try and help them preemptively or ambiently in the background. And so we made something we called Ambient Lionel. I don't know if you've seen it, Naval, but there is a Lionel Richie music video from the 80s where a woman carves Lionel Richie's head out of clay, so she can kind of like have a nice image of him.
Yes, I'll put that link in the for
yeah, it's in there. I'll drop you that link. And we carved another one out of clay, and put a Raspberry Pi inside it, hooked up to Google Speech to Text, so that when you said hello, it would sing back to you, "Is it me you're looking for?" Lionel Richie says.
Amazing.
And so it was a silly little thing, but it was, we were trying to show that this technology was ready for it, and that we kind of go in the future. And then, of course, the next year, Amazon released the Alexa, which kicked off that whole movement. So we were right about that one, which was nice.
Yeah.
It was kind of my first introduction to AI in the cloud and at the edge, and that has been. I never like decided to go this direction through my career. I did an interactive media degree at Bournemouth University, which was. I didn't know if I wanted to do computers. I didn't know if I wanted to do media studies. So interactive media was a nice kind of divide down the middle of I get to do computer and media studies. And of course, I gravitated more heavily towards the computer science side of stuff. But for me, with that kind of media and humanities side in there, it made me realize something, which is you can have the best technology in the world, but if someone doesn't understand how to use it, if it's not something that people can interact with, if it's not something that's designed well and intentionally, then it doesn't matter. You have a black box that can't do anything, right? It's pointless. Humanity and people need to be at the core of all technology. And that's been the thread that's kind of followed through my career. After that, I went to the Financial Times, where I continued that line of work again, more speech, text, speech, edge AI stuff, cloud computing, went through to IBM, to become a developer advocate, my first developer advocacy role, because I wanted to help people understand how these technologies work. Again, you did the same. And I wanted to show people that, hey, this isn't something that's so far removed from everyday experience. That it's, I think a lot of people try and paint technology as this kind of, magic ethereal thing that, kind of like wizards or priests, like only certain people can divine how this stuff works. But, I'm the son of a bricklayer. Who didn't have, his first computer he cobbled out of things he bought at car boot sales. If I can understand it, anyone can understand it. And I want people to believe that that is something that they can actually do. And so being a developer advocate at IBM, it certainly helped me kind of shape a space for myself in the world where it was my job to help people build things.
Yeah.
And I continued on to AWS, where I ran the UK and Ireland's development program for just over a year. I took a year out to build my own thing, which, didn't work out because most startups fail. But hey, that was a fun experience to go and learn. I then ended up in a fintech for a while, where again, we were trying to help people understand how technology, open banking, open finance can be used to enrich people's lives, to enhance the well-being of themselves, their communities, and their companies, right? And most recently, I've ended up at Expanso, which, we the thing that we say, those kind of, those responsibilities, is that we're not trying to build something that's just a piece of software. We're trying to change the way people think about how they do computing. Because we've all built with Kubernetes, we've all built, applications on PaaSes like Heroku or Cloud Foundry, all incredible pieces of technology. But the problems that we see people trying to solve in the ways that we're currently trying to solve them, we don't think it fits anymore. So we're not just trying to build a technology platform, we're not just trying to build a software product. We're trying to get people to think differently about how they actually orchestrate these things at an abstract level and the benefits that are kind of there. So that's where we are now. That's what I'm doing currently. Throughout all of that, I've tried to keep things light and fun and interesting. Most of the projects put together, if you have 1,000-yard view of them, they'll seem quite silly. But the whole point of them is to get you interested in them. If you can make something interesting, people pay attention to you. If you can make something useful, people will see the value in what you can do. So if you can make something that's silly but clever, people go, that's interesting. Oh, and it's useful. And they get far more attention. People's attention spans are terrible these days, but it gets far more focused consideration. And that's something that we're doing very much with Bacalhau right now. We're trying to make interesting, nice, fun, clever things that show actually there's this really powerful technology that underlines these things that you can deploy from something as small as a Raspberry Pi to as huge as one of those crazy IBM Z mainframes that we used to work with, right? Like, people don't realize the amount of raw compute power in those things, and they're in so many of the FTSE 1000 companies, but people don't think about how that stuff works. So that's what we're trying to do. We're trying to challenge that, trying to get people to rethink how they do these things, and we're trying to give them the tools to help them build that out themselves.
Yeah. So that's a lot of cool information, but we'll start with the guy where the school teacher rolled in a box.
Mm-hmm.
how? So I'm talking to the same boy. You are talking to the same boy or the little kid.
Mm.
So how did, so let's say, so computers or technology or fascination with technology, and that's where 1996, 97, that's where the entire dot-com was at its rise. Till 2000 itself, till the Y2K thing came into picture, dot-com was going really big, and they were like whiz kids who were reaching to computers. There was a lot of concern among schools that a lot of folks who are not rich enough to afford computers, they might miss out on that. There were government grants given out, and that's true across countries, because that same thing happened in India as well, and I'm sure that would have happened across the world as well. That government would have wanted to increase access, like something similar happened during COVID as well, that folks who could afford a laptop, could afford a mobile phone, could afford a tablet, those kids didn't have their learning impeded. And that's where organizations like IBM or larger organizations like Accenture, they brought out a lot of the reclaimed back older computers which are lying there. They just took out them like in the big boxes. I could see the pictures of them wearing masks. Such a noble cause, I must say. So, because it's lying there in inventory, its value is less than £100, $100. Let's give them to schools. We'll clean them, decontaminate them, whatever. We used to spray those stuff, and then we'll ship them to home so that kids can turn it on and at least start learning, right? Because the entire factories were closed down, the e-commerce stores didn't have enough shipment, everything was stocked out, so they made things available. Why I give the example of an unfortunate epidemic is because that was exactly the situation way back in 90s as well, but not because of epidemic, but because of cost of computing. That the compute was not as decentralized, and I'll use the word democratized, so that everyone can access. And now with, of course, post IBM, post AWS, even the higher power of compute, or now with Colab on Google, even the AI is available for, you can rent a Tesla GPU, you can rent something on Colab. If people know Kaggle, then Kaggle also allows lot of free resources, lot of free cloud storage. So, but those days came much later. So tell me about that boy, and how did the neurons fire that day? For what happened that day in the classroom?
So, yeah, it's a very long time, but the moment stuck with me. So, the dot-com boom was going on, but it was changing the world. It was the information superhighway, surfing the web. This thing called the internet. It wasn't something that really reached my town. Like, there was ways to do the internet, whatnot, but I come from a town called Luton, north of London, about 30 miles. We're very close to London.
Yeah.
But
I know Luton. Luton has been immortalized in the movie by Gurinder Chadha. It's about the boy who plays the boss.
Blinded by the lights.
Blinded by the lights.
They shot that in Luton. That was a couple of years ago now.
Yeah, that's Luton. I love that movie. It's Bruce Springsteen. Bruce Springsteen as well. Wonderful. Oh man! So you're from Luton?
I'm from Luton. Yeah, that's
amazing.
Me. And what Luton is a wonderful multicultural town. We have the largest one-day carnival in Europe. My family are from Ireland originally, largely. Yeah. So there's a huge Irish community there as well. They came over to build infrastructure in the United Kingdom. So the M1 motorway. My bagpipe tutor was one of the guys who was site managing the M1, the first motorway in the UK back in the 60s. It's so incredibly rich, diverse culture and history, and I'm always grateful that I got so many experiences growing up with these kind of people. But one thing we didn't have was a buzzing tech sector. So the internet and the World Web, like there were things.
Tell me a bit about Luton, if you sorry for interrupting. So tell me a bit about Luton, because a lot of people in India know a lot about Luton from the movie. They also know of towns like Wrexham, because Ryan Reynolds, Welcome to Wrexham, so popular. It's a mining city. It has shown the entire journey. The previous season of Wrexham had the entire video of people coming out of coal mines and stuff. So we know about Wrexham, for example. So paint us a picture of Luton, and then
Luton is a very old place. So it was mentioned in the Domesday Book back in, I think it was like the 1076, so it's almost 1,000 years ago. for those who don't know what the Doomsday Book is, it's a very old British document that William the Conqueror had created to basically take an audit. What's in Great Britain? What is there? And there was a town mentioned, which was basically Luton back then. So it's been around for plus 1,000 years. It's an ancient place. We have one of the oldest churches in the area, St. Mary's. But the history, the kind of background of Luton was longest time farming, agriculture. The crest of Luton has wheat and bees on it because they were a critical part of what we're doing. Some of the landed gentry there. And over time, one of the first major industries during the Industrial Revolution that spun up in Luton was hat making, milliners. We had straw, in abundance because of all the local agriculture. And the thing that Luton got really famous for was making straw hats, which is why the football team in Luton, they're called the Hatters. Right?
Oh,
and
amazing.
yeah, they called the Hatters, Luton FC. That was a thing for centuries, throughout the Victorian era and whatnot. Most of what you'll see in the museums in town, there's the Wardown Park Museum, which shows the kind of rich cultural history of Luton, back, from 100 years plus ago. A lot of it is about how to make a good straw hat. And that was what we're famous for. Of course, with the Industrial Revolution, everything else changing, industry changed, and whereas Wrexham was a mining town, Luton became a manufacturing town. It's very close to London. The first railway station was built through Luton about 120 years ago, so the early 20th century, maybe slightly before that. That was a huge, massive growth for Luton.
What kind of plants? What kind of factories?
So it was car manufacturing.
Wow. Jeremy Clarkson would have a field day here. The entire Jeremy Clarkson and...
this is the thing, right? So Vauxhall was headquartered here for the longest time.
That's the reason I'm thinking. So I have been like a diehard fan of Top Gear till Jeremy Clarkson had a fight and quit the show, and then I've gone to the other one, the Grand Tour, the GT and TG there. I also saw that video of Jeremy Clarkson coming out of the BBC, sitting in that car, and then going
to the airport.
So I'm a diehard. I've watched literally all the episode of Top Gear. And Top Gear is very popular in India as well. They've seen everything, and so that's the reason I was thinking where I have heard the word Luton, because Jeremy always had a thing about either the sparrow flying faster than the speed limit. He'll put a picture there. Or then I remember I've heard Luton so many times. Where have I heard Luton? Then I remembered. Vauxhall. So he would talk about Vauxhall Astra, Vauxhall this, Vauxhall that.
Exactly. And I think most recently the Vauxhall vans, the Miranas or the Mivanas, I can't quite remember what they call it at the moment. But that was like the manufacturing for most of the 20th century in Luton. Then the airport came. So Luton Airport is the largest small airport in the UK. So you have, the more ones like Gatwick, Heathrow, Stansted, all the other ones. There are regional airports too, like John Lennon in Liverpool, Manchester, Bristol, all these things. But the largest of those is Luton, and it's because of its proximity to London. There's a tram and a train direct to London from there, and so that is like the main kind of economic hub of Luton these days. The airport provides and sustains a lot of what the town does there, and because it's so well connected to London,
it's a bit like New Jersey. So for folks who New York is too expensive, one say New Jersey. So Luton is to London is what New Jersey is to New York.
I've never thought of that way before. That works. That's a good analogy. Yeah.
That's how we cross-cultural collaboration, CCC, brother.
That's how we do it. It's how we do it. And so, I grew up in Luton, but again, the web wasn't impacting life there. So the .com thing kind of passed me by a little bit. But before that, we had Acorn Computers in the UK. And they were a huge British computing manufacturer who built the first BBC Micro. So that was in every school in the 80s. And then they became like a huge consumer market, consumer grade hardware too. And the government did put computers into every school. And I remember that my teacher...
Whether it's private or public? So all schools were public or private schools?
Both, as I understand. So I went to faith schools. I went to Catholic schools growing up, and they were wonderful, wonderful schools.
Yeah.
And so I think it was actually the church that put the computer in the school.
It's so amazing that they are modern enough to have those things there.
And it shows how important, how widely recognized, how important that revolution was. That everyone had access, that people are given the opportunity to be exposed. Because not everyone's going to work in computing. Not everyone's going to want to be a software engineer or a DevOps or an AI engineer. But people will always have the opportunity to explore those things, as I did. And I found that what I really liked was the fact that you can create anything, literally anything. We back in the 90s, it was very much like, what can we put into the computer? But I was always interested, what can you take out of the computer? So now we have like 3D printing. You can print a house with a computer out of concrete. I needed a pen pot a little while ago. So I printed one out of my lunch break, and I have a little pen pot that I can just stick on my desk,
Yeah.
We had to repair a kettle a little while ago. So I printed a little latch to do it. But these are things that you can design in the computer and output it. And we can also, what the computer is the key at is, I think Steve Jobs called it a bicycle for the mind.
Yeah.
It's something that can make people go far further than they can on their own, because it's an extension of thought, right? You can create insights and generate data so vast these days that you can make better decisions quicker about anything that you're doing. And so that's something that never really left me. Everything I've been exposed to in that time, since that first computer, I'm getting old, Naval, nearly 30 years ago now. That would have been 1996. So yeah, we'll have to throw a party or something. It just kind of blew my mind that if you sat with it long enough, you could do anything in time. I have a wristwatch here, nothing fancy, it's just a little thing I picked up a little while ago. There's more computing power in this than there was on the Apollo moon lander. And all it does is tell the time. And so to your point earlier on, where you have all these kind of secondary computers, these refurbished computers being given out. We live in a culture where people want new, fast, shiny. But thanks to this glorious thing called Moore's Law, even the things that are, older are still vastly more powerful than was available 10, 15, 20 years ago. I can run AI in my laptop, which I couldn't have done 5 years ago.
No.
And in my smartphone, there's more computing power than I had in any computer up until 2008. It's astonishing, and so it's wonderful that with such availability of it, you never know who's going to build what where, and what they're going to be able to do with it. So yeah, it's a wonderful thing that I've been exposed to these things, been given the opportunity to build with these things, and now I help people build these things too. Again, developer relations. It's about helping solve problems. We all have problems. That's what we do. The books that I wrote, they were on game design. I'm not a game designer, but I can build video games. And the reason I wanted to do that was my personal ethos is, if you can learn to program Pong, you can learn to program anything. Because it teaches you user input, it teaches you animation, it teaches you sound design, it teaches you, control logic. It's the foundation upon it. And so that's why I put those together, because I need to sleep. I can only be in one place at one time, but books can go on forever. They can be a thing that you can pass around, and the knowledge is in there. It's like you have my brain in your hands, so go and do something there. And that's my contribution to someone's journey. And it has been really nice. People back in the old days on Twitter, if you remember Twitter, would ping me saying, "I've just read your book. I've built this thing. What do you think?" And it was great. People were extending stuff, and they're experimenting, they're putting their own kind of style and flavor on it. And yeah, it was just wonderful to enable that. So
I was just Googling up what is Pong and everything, because
first video game, classic. One of the first video games back in the days. It's basically tennis on a 2-dimensional screen. It's a little ball bounces around.
Understood. Yeah. So then you just move that slider. It just bounce back and come here and hit. Then
that's right.
Now I get it. I was like, what is Pong? Okay. Yeah, I've played it till the Kingdom Come. So I have played it so many.
It's classic. It's like most people's first video game, but it's so easy to just pick up. There's no instructions. There's no, here's how you do it. There's a ball moving around. It goes on the screen. You lose a point. So okay, well, I can move this control. And then it bounces back. Oh, I get it now. And it had its first kind of AI in there as well. The paddle was played by the computer. It had to figure out where the ball was going. And it's trivial. You're a software engineer. I'm a software engineer. We know how simple that logic is. But back in, the 50s and the 60s, when they first put this thing together, that wasn't software. That was encoded into hardware. That was like raw transistors and capacitors making that move. That's intelligence in metal, which is kind of crazy to think about it. We don't think about that stuff anymore because we're so far abstracted from it. But it is just bonkers to think that ever existed on its own.
Yeah, that's a great insight. That just like our older cars or washing machines, refrigerators, which have auto spin cycles, they have custom 8085 microcontrollers, 8055 microcontrollers, 8085 processors. They're very older processors.
Plastic.
But 8086 Those are the days there used to book called Boylsted and others. I remember the Cedra and Smith. There used to be a couple of books. They would all were 8055 microcontroller programming. We used to use them in robotics and cars and stuff. We'll burn those ROM. There used to be these ROM burners. Put it up, burn that ROM, and then it's like those of CD burning and stuff.
This is the thing, and what's crazy is, I mean, you can buy a computer, a Raspberry Pi. I've bought so many over the years for my various projects because it's a Linux computer with a decently powerful CPU for $35. And I remember back in 2016, they published a magazine called The Magpie that they used to write for, and the giveaway gift. If you remember that some magazines you had fake tattoos or pens or glow in the dark stickers. The gift was a computer, and it cost $3. So there's a huge array of things to be able to explore and experiment with these things, and they are in everything. I'm currently sitting in a 12-year-old car, but there's more computers in this than people realize. There's a stereo system which has radio receivers doing Bluetooth. There's a heating system. All these little systems talk to each other in these reactive ways.
Forget about those. My mind was blown. I was watching. On Apple TV, there is a show called Hijack by Idris Elba. I don't know if you have seen that series.
No.
Okay, no. So there's a scene where the hijack is happening and something. So a lady who is in the Secret Service in the US, so she gives latitude, longitude code, and she tells that I'm giving you a code. Don't put this code in any sat nav or GPS devices. Just look at that and then burn the paper and whatever, go there. Then I was thinking that GPS and sat nav came in those days of US military tracking before they made GPS free. And I know it's very obvious thing, and listeners will think that I'm going crazy. But 3 months ago, I realized GPS is free. GPS and GPRS are two separate things. For GPRS, you need a data connection. It's a 2G. GPS is free. So even if you don't have an active data plan on your SIM, with just GPS, so why would a country like America give a satellite for free? That use my satellite. They have spent millions, if not billions of dollars to take the satellite up, keep it up there. So what blew my mind was that in 1970s, so if something is playing on radio, it's a completely analog device. It's just like a Yaji antenna. It's used to be just on top of our homes. This is then you can't store anything. It's completely analog stuff, right? GPS is completely analog. It's just sending an electromagnetic signal to the antennas of the satellite. If it's in the geosynchronous orbit, it catches that signal and it triangulates your location lat long with this, and it tells you where you are. So if you order on Deliveroo or if you order on some other food or an Uber, it picks up your location, it picks up cab driver's location, it figures out the Manhattan distance, then it figures out the rate, figures out the time, so what charges it can put, and then it tells you he or she will be coming in the next 7 minutes or whatever. So for that GPS does all the compute. It just so it's like I point a torch on a glass, light hits and light comes back. There's no data happening. It's just analog stuff. But when you hit a GPS satellite, you are I assume there used to be zero compute power up there. How is it doing math and telling me I am in Bristol or I am in Mumbai? How does it know? How does it do that? Tan theta, sin theta, cos theta. How does it do?
So what's particularly crazy about GPS is you can use it to confirm Einstein's theory of relativity.
Yeah.
Because the satellites are further in orbit than they are. And so if you're near a center of mass, I believe time moves slower.
Yeah.
Whereas if you're around a black hole, time doesn't move at all. But on Earth, if you're at the bottom of a mountain and you're at the top of a mountain, at the top of the mountain, time is moving slightly faster for you from a relative observer.
Yeah.
So satellites are in orbit. They're further from the point of mass, the Earth. So time moves at a different rate for them. So those GPS signals, those satellites, they have to calculate the adjustment in the flow of time passage so that the GPS is correct. But if you get that wrong, if you get the timings wrong, you're not in Bristol, right? You're over in Wales. You're about 50 miles off, depending on how big these things are. They do. So, it's a wonderful physical demonstration of a thing that is, a theory that a man dreamed up in his head 100 years ago. Brilliant man. But we see that applied in our lives every day. When it comes to how GPS works.
And the best part is it's free. If they start charging a cent a signal, then imagine the amount of overheads that Uber would have. And even then, we are using that free technology marvel and the free compute. When you're talking about Raspberry Pi, we're talking about compute changing our lives. GPS is the best example of compute out there.
And this is the thing, good things happen when you put things out in the world. Think of, again, Deliveroo is a great example of, you don't need to know where your driver is. You just need to, because in the old days, you'd call up a takeaway. You'd like, hi, I'd have, XYZ, please. And then you'd know within the next hour, someone would turn up at your door and you'd get your food. With GPS, it's not something that Deliveroo needs, but I do it. I'm sure you do it. I'm sure most people
100%.
listening will do it. We watch the man drive on the bicycle through the, the little icon, and we know when they're going to get to the door. And it's a silly little feature, but it brings you confidence that that food is coming, that the person's not lost. The amount of times when I was younger, I had to go out into the street and be like, where are you? I'm over here, and they would have to figure out how to find me. Whereas now I can say it's in this point on the planet. And I can see them coming to that point. If they do get lost, well, that can still happen. I can say, you're around the corner, turn left and you're there. It's not something that was ever designed for intended use. No one was thinking when they were building the GPS satellites, oh yeah, we're going to use this to deliver sandwiches. No one thought that. But when you make these things available, when you make them free or, incredibly cheap, it becomes like air. You don't think about breathing. You don't think about calling someone. It's just something that is done right now. You and I are doing a video call, and again, we're tech guys. We understand what's happening in the background for you and I to send video to each other. I'm doing this from a car over a radio network, which is being bounced around several servers on the planet to get to where you are, and vice versa. And it's happening with less than a second of latency. But you don't think about it in your common life because it's just there. And when you have those things available to you, you think, okay, cool, I need to do a video stream. Brilliant. I'll go and do that. There are tools to help you. And so many of them are so available and free to go and get started with. It's absolutely, the innovation will never cease. There's always something new. There's always a new take. There's always different direction. It's something that, again, we're trying to do with Backroyale. We're thinking, okay, we see how people are trying to process data in all these different places. We think it can be done better in a different way. And we stand on the shoulders of giants just like everyone else. I didn't have to go and invent Linux. I just had an operating system there. I don't even think about spinning up a web server. I push a button, I get a server in a data center somewhere automatically. Could you imagine how hard it would be to build anything if you had to manually compile an operating system and then get that to a data center on a disk and then have someone put it in? Nothing would happen. Nothing would happen. But we now live in a world where you can push button and receive anything in no time at all, and you can just build things. I think that's been forgotten in recent years. You don't need permission. You don't need to ask somebody. You can just build things. Linus Torvalds didn't think, I'm going to ask my university if I can build an operating system. He just did it, and people picked on, went, this is great. We're going to build in it, and now it powers something like 90% of the internet. It's astonishing, and it's just out there, and there are thousands of different versions of it. People, you can just go and do stuff, and things like GPS, they are more intentional. There was a need for that kind of technology. It'd be good to know where we are, how we're going to do these things. So those sort of things there. But again, the consequence of them being available for anyone to use, at the very least, you get incredibly reliable clocks. GPS as a time signal, you can just get some off-the-shelf, hardware, which is a radio, which has existed for 150 years now, and you can figure out the time wherever you are. It's astonishing. It's astonishing. And so it's always nice to, sometimes the immensity of what's available to us all kind of breaks my brain a little bit, and it just gives me the umption to go and do stuff. And that's when fun things happen. I love to tinker. I love to tinker with other people. Hack days are phenomenal as well. And I'm very, very lucky that I've had so many opportunities to make things in my career that help people get going.
So why I mentioned this, of course, because of the Expanso and the entire project behind it, Backroyale project. I'll
you got it. You got it. You're there. You got it.
Thank you. So why I mentioned this is because one is open source, so that the accessibility is in the challenge. Second, being available for people to download and play around with it, figure it out. That increases access, and people will play around with it, break stuff, make a playground, understand something. And then that's very essential, because you never know what people can build, and that's where the availability, awareness, and the usage comes. A lot of open source projects have taken off. Apache had ton of projects. Yesterday I was in the MongoDB event here in Mumbai. MongoDB is a classic story of how you could have distributed storage and have data streams coming in, which where so people used to say we have SAP, it has we have CRM, we have. There used to be this coupled modular, very. They were very tightly coupled. We needed loosely coupled, tightly aligned, as we say it.
Yeah. They were products. They were products. They weren't tools. And that's the difference. Like, products are great if you're trying to solve, specific problems.
Yeah.
Really specific problems. And we even have our own kind of products, and we're thinking about what kind of products can we build. But tools are the things that people use to build other things. One of the things that I like to draw an analogy between the kind of open source software that piece stuff together. Is it's like glue.
Yeah.
You don't think about glue, but glue is very, very useful when you want to put two things together. Once it's there, you forget about it. But without the glue, it can't happen. Without the glue, it can't happen. So I always look for things that are like glue. Things that you can use to stick other things together and make something useful and grander than the thing that is underpinning it. Because it's critical. It's absolutely critical. And products don't offer that. Products solve problems. And if you are trying to solve that problem, immensely useful. If you go outside that box or that definition of what can be solved, that's when you start to struggle. And that's when you start thinking about, okay, well, what can I use that will solve this problem? What can I build with that's going to go and solve that problem? And so, that's kind of that's how I kind of view those two sort of things.
Yeah. And before we go a bit deep on the Expanso and the open source project behind it, what fascinated me, or what I often used to talk about say products like Uber Eats or Deliveroo or other platforms. Food Panda is there in India. There are other delivery platforms. I used to say that for them to work, as you mentioned, I could order some hot pizza from some nearby restaurant. Domino's have been in existence for a zillion years. Even dinosaurs used to order from them. I don't know how the dinosaurs used to eat them. They had little hands. But the point is, I used to say that for me to order food on Uber Eats, I need to have a smartphone. The smartphone needs to have an operating system that supports an app store. The app store needs to have a Domino's app. And then so that they couldn't have done in 1990s, because at that time there were no Android and Apple iOS. There used to be Symbian phones, Symbian S30 phones. And the first one was the Palm Trio. It used to have and those stuff. So for them, so they didn't have the concept of app store. The app stores needs to have developers. Developer needs to make apps. The companies need to come up. So there's a lot of standing on the shoulder of giants. Then you come. Then when you talked about GPS, so we talk about value-added services. So suppose if you have one service, can you add value on top of that and charge for something? Red Hat is a classic example. The entire community is free. For server, they charge for some money. That made me thinking that Google Maps itself is a value-added service, because GPS is free. I can buy a one-time, say, so if I can buy £100 or say a 1,000 rupee or a 5,000 rupee or £100 device, which I can put on my car till the kingdom come, and that device has a GPS in it. Or if my car comes with inbuilt GPS, I don't need Google Maps. If car has an operating system that doesn't go outdated, because nowadays at least my Honda car has because they will control the OS, they will not block the update, they will block the apps. If I can handle the car OS and my car has GPS, that GPS is free. You are taking a free GPS, you're making me tougher to get by adding GPRS on top of that. Then you make me use a 2G or a 4G signal. What Google Maps does is that it takes free stuff, and then it adds value-added services, it adds petrol pump, it adds supermarkets, it adds a lot of stuff. But what if I don't want? What if I just want to go from point A? I just put in some numbers, 111 to 222. That's it. I don't want to know where 222 is, a school or a dispensary or a food stop. then I should be allowed to go, right? You shouldn't be able to force
again,
me.
this is part of the joy of the internet as well, APIs particularly. Being able to pull these things in and glue them all together in the way that you see it. Google with their Maps product definitely have an idea of the kind of information that people want to use. I mean, I use Google Maps to get where I am right now, right? Because it's nice
I
to
do
have
all
the
the
GPS
time.
to know where I'm going, but at the same time, it's nice to have that extra bit of layer on top, which tells where the traffic is going to be. It's nice to have that little bit of extra layer traffic on top that says that actually I can get coffee nearby soon afterwards, which I did. I'll hide the logo, but it's there.
No problem.
But yeah,
we need the money. We have an independent podcast. We need all the money we can
dollars. Yes. But
yeah, amazing.
And so these things, when they're about and they're out in the world, it's how you combine them. I've always thought there'd be a nice. I love driving. Big fan of driving. Absolutely adore being in a car. But when you use like a GPS system, its primary aim, and its aim for 90%, 99% of people is to get you from A to B as quickly as possible, the least amount of fuss. What I would like is someone to build me an app that gives me the nicest drive possible, right? Through a pretty place or through a vista.
Yeah.
So, it's having that information out saying, okay, well, what exists? Are there national parks nearby? Which, again, the government makes available. Is it that there is going to be a lot of traffic on this one nice route, but actually people like this other one? And some of the most delightful drives I've had have been when there have been traffic jams on the motorway, and I thought, you know what, bugger this, and I've turned off. I've just kind of ambled through the countryside, and they're gorgeous. It's like, I wish I could record this, like a Strava for cars almost, to say, this is beautiful.
Actually, you can do in Strava. You can turn on that, and you can. My sister does it all the time.
The problem I've got there is if I share it, other people will do it, and part of the fun is being on your own. So I've got to hoard a little bit to myself. Got to keep it myself, But I can still build that with tools.
Yeah.
I can use the Coco SDK on iOS to build an application. I can use an MQTT broker to take in my GPS data points and store them. I can store those in an SQL-like database and have the information there, and I can use the web to deliver it back to myself afterwards.
Tell me
so I
something.
can see these things.
Tell me something. Before Google came, so say in 1995, so GPS has been there since 1960 or 70. Were people using free GPS before Google came? Before data in cellular came? Before 2G came? Were people using GPS, or why were normal people not using GPS?
It's one of those things, like it's a couple of things. Again, Moore's laws into play. Like GPS was available, but the devices to make use of it were expensive.
But we used to have radio, right? We used to have FM radio, shortwave radio. For example, one thing is we had analog devices to listen to music, like BBC when Voice of America, whatever. Why didn't we have an analog device to travel?
Well, it's because, like, think about it. You need some way to store maps. And so back in the 90s, a gigabyte hard drive was about this size. And if you want to have, maps for the planet or for a country, it's more than the gigabyte, in JPEG format. So it's about storage there. So GPS, the reason we have it like so readily available now and all these things on it is that we have lots of very powerful devices that are very, very cheap. Like so this call I'm running through right now, I'm running through a $80 Motorola. It is a cheap phone. It is awful, don't get me wrong, but it is also more powerful than anything that was around the 90s. I can store 128 gigabytes of data on there. So I couldn't put, the entirety of Google Earth on there or anything like that. But if I had something that had, in the 90s, 128 gigabyte storage, it would be the size of the car. So we live in a time where those things are small enough, they're cheap enough.
Why don't people do it now? I'm pretty sure the MI5 and all the secret agencies must not be using Google Maps. They must be using like that Google Earth and their own.
You can download OpenStreetMaps.
You don't need OpenStreetMaps. Yeah, you don't need Google Maps.
I think you can download the entirety of Wikipedia in like 120 gigabytes.
Yeah, at least for the traveling purposes, if you don't need live traffic data. Less like the old New York Hollywood movies have the taxi drivers talking on the radio that, hey, there's traffic jam here. There's a police radio live for everyone available to see the traffic jam incident. If you don't need live traffic data, you don't need that. So you can still use that.
Bonus. It's a nice bonus, Like I said, I'm in Wales. I'll be going through the national park, Banau Brycheiniog, I think it is in Welsh, the Brecon Beacons. And there's not internet throughout the entirety of that park. There's limited connectivity. So there will be times where I won't have traffic, but I still have that route stored in the system, right? That it knows I need to get from place A to place B.
Yeah.
And if you can't store my information for later, like I do like it to track where I've gone so I can look at the maps afterwards. it just keeps on the device. And then when I have internet connectivity, it sends it off again. And that's something that we do with Bacalhau as well. Having data on device, keeping it at the edge, and when there's connection available, we send it on so you can do something with it later on. So we do live in this time where.
Tell us about Bacalhau and how is it being used. I read a couple of your developer event stuff. It talks a bit about role of edge computing in BFSI, how it improves performance and scale and stuff. Tell us a bit about what it does, Bacalhau, and then the commercial arm or so in ServiceNow there's a concept of now and now where we talk about drinking your own champagne. So if you make something, why don't you use it?
Yep,
so you folks made it. You said we'll be our own first customer because we'll get all the big bats straight from here. That concept used to be there in IBM Garage and IBM as well. That if you make something, get all the big bats from the people who you can put arms around and be friends after grab a pint of beer after talk a bit about the journey. What is the market space that you saw it could fit in? And then how did the champagne come into existence? Why did Expanso decide to drink their own champagne? And then how the journey started?
So, okay. So the journey. So Bacalhau means cod in Portuguese.
Why did someone want to make Bacalhau?
This is the thing. So COD stands for compute over data. Right? That's what we allow it to do. Right? So compute over data.
Nice.
CEO David Aronczyk, our CEO David Aronczyk, he was one of the main instigators of kind of Kubernetes and Kubeflow. He was very, very much involved in that kind of process.
Kubernetes was Project Borg, right? In Google?
Sorry?
Kubernetes was Borg in Google, right?
I think so, yeah. I think it was bought, but a lot of Googlers were involved, certainly. I'm not sure exactly where it was, but Dave was one of the people kind of pushing that forward because Google saw that they wanted to be able to have a standardized deployment interface for their applications. When your company is big as Google, you don't want different teams, different places deploying things different ways because it reduces portability. It makes it hard to change things. If you have a standardized interface, then it makes things a lot easier. You can drive innovation and outcomes much, much faster. And Kubernetes is great. We adore Kubernetes. But when you have a Kubernetes cluster, it grows to a certain size where it hits the boundaries of the platform it's in, right? It hits the boundary of platforms and it's still fairly centralized. So you can have, a Kubernetes cluster in Azure, you keep adding pods to it, but anyone who's ever done it, it's really hard to have those pods be in a separate AWS account or in a separate region. So bringing those systems together is very, very difficult. And so David started thinking about, okay, how would we want to do that? Rather than having a centralized kind of managed platform for deploying workloads to where they want to go.
Yeah.
How would you do it differently so that it doesn't matter that a node is in one platform or one country or isn't always available, right? And so that's where Bacalhau was born of. Bacalhau kind of flips the concept on its head, right? Rather than trying to, and if you think about how most companies, people do data processing, for example, how they do it, they bring the information to where the compute is. Right?
Yeah.
But I don't know if you've ever had like an S3 bill, but they can get big because it's not the storage of the data. Storage is cheap. Moving it is expensive.
Yeah.
And when you move data, particularly these days, you have to worry about where it's going. Is it encrypted in transit? Who is it passing through? Does it need to stay in one place? So with Bacalhau, we thought, why don't we flip that on its head? Instead of moving data to where you want to process these things, which is slow, it's expensive, it takes time, it's complicated. What if you could move your programs to where your data already is? Keep your data in place, keep it secure, keep it within your existing governance structures, keep it inside the country that it's in. If you think about things like GDPR and HIPAA and all that kind of stuff, moving data is not really allowed, it has to stay where it is. What if you could define an application and say, hey, I need this compute to run over here. But if I have a petabyte of information and I want to process that, I have to move a petabyte of data. Expensive, slow, fast. Remember, the fastest way to move a lot of data is to put it on a hard drive and attach it to a pigeon. Right? That's still the fastest way to move data. Right?
I remember Amazon used to have this big snowmobile.
Yeah, snowmobile. Yeah. That's the thing, because it's still the best way to move a lot of data. The internet. So anyway, moving data is expensive and hard, and you've got to keep it. So we thought, what if you can move the application to where it needs to go? So you need a couple of things there. You need some way to define the places you want to process things. You need some way to get an application that can run all these different places in it, and you need an interface to be able to define that stuff. And that's what Bacalhau is. Bacalhau is a way of saying, I want these nodes to be available to compute over information on those systems or near those systems. And I want to be able to push workloads to where that stuff is. So with Bacalhau, the CLI, you can say, I have this application, it can be in a Docker container, it can be WASM. You can say, I need it to run in these countries, or I need it to run on this kind of compute. Bacalhau communicates with the node, says, hey, this is the application you have to run. The application, the node gets an application and runs it in place over the data, and then makes the results of that application available back to the person that communicated with it.
That's amazing.
So really good for ETL, really good for pushing AI models to the edge. You know, one of the hardest parts about building AI is not the building of AI, it's getting it to where it's going to run afterwards. But if you have 1,000 devices, or you have devices with unreliable connectivity, it's really hard to manage that. So we built Bacalhau to do it automatically. That's part of what it does there. Yeah.
That's amazing, because I remember, so a bit of my, I worked at Indian Oil Corporation. Indian Oil Corporation is a nationalized oil company, and bit like it was started in India post 40s or 50s, and it's India's largest oil refiner. And energy companies are known to be, especially oil exploration companies, are known to be very big on data. And the entire refineries and those, they have tons of data coming in, both from IoT sensors as well as data coming in from the processes that are running. One is for definitely they keep it dumb just for the auditing purpose, because they want to be safe from when the KPMG or the PwC guys come on knocking. They want to see what happened on that day at that shift and that batch.
And that's really hard, really hard to do. You know, because you have lots of devices in lots of different places on lots of different systems. And always not, you know, oil rigs, particularly oil wells, they don't have connectivity in the way that you and I do, right? They don't have that infrastructure available to them. So we wanted to build something that you could put on those devices and say, hey, when you're available, I need you to run this workload, I need you to run this application, I need you to run this code, and give me the results. So you can, and again, the case of, you know, oil refineries, you could say, actually, I want to be told when any sensor detects that the temperature is above a certain temperature and alert on that. Or I want to know what happened over the last 24 hours, but only give me the key points. So rather than egressing, if you have like second level latency, you know, that's 60 pings every second, and it's, you know, 60 pings every hour, times by 24, times by 28. What you can say is, actually, I don't need to have all those data points. What I actually need is average over the day. So and crunch all this data and give me the hourly output. And if there is a peak there, you can say, okay, unusual, let's investigate that further. So rather than having to put a needle out of the haystack, you're able to reduce the haystack to better find the needle with a magnet as well.
Yeah, that's actually a very good example and a very good allegory here, because a lot of decision making actually happens at the factory level or at a plant level or at an assembly line level. So there's a manager who's sitting, who's supervising its construction, when the manufacturing is making, as simple as making a car, or whether it's a robotic arm which is working. And a lot of decisions are not taken at headquarters in Mumbai. They're happening at a plant somewhere, which they're like 10 plants which has like 100 managers, like 1,000 people taking decision. That's where the production, the assembly and batch processing happens. So they take decisions. So of course the CEO of BMW gets a Tableau dashboard which says how many BMW cars manufactured in Japan, Asia, Japan, India, Britain, Australia, whatever. But that CEO of BMW sitting in Germany doesn't need to know exactly what happened. If he wants, he can click. But real time right now, which car is having what defect, which floor, he doesn't need to drill down. But the guy who's about to take, guy or the girl who wants to take that decision at the assembly line, they can't. So why I'm saying this, because both of us were part of a Big Blue, and opposed that SAP also had Leonardo IoT, IBM had Watson IoT, and there used to be a lot of OpenWhisk applications as well, serverless applications, which you should remember those days.
I remember OpenWhisk. Yeah, I loved OpenWhisk. It was great. It was really good piece of stuff.
Those memories coming in, because SAP, Leonardo, and then of course the big giants who actually make these machines, like Siemens or Honeywell. What they do is that they club their own I'll not use the word bloatware. I was about to say the word bloatware, but because they make the
proprietary
equipment.
systems.
Yeah, yeah. So they also put in their own allied software with the big heavy machinery, and a lot of people do not want to use a Honeywell software. They do not want to use a Siemens software because it's very clunky. It takes so much time to understand it, and it's very monolithic. It doesn't talk nicely. It still requires an ODBC or a JDBC driver, which itself, I would rather have a multiple root canal treatment done rather than connect to a
yes.
so even less anything lesser than a REST API, even a SOAP API makes me say, why did I get out of the bed this morning? But then,
and this is another thing that we tried to solve. We wanted a standardized interface for any kind of compute workload, right? Like, I think the factory versus the CEO thing you mentioned there is very interesting, because you're right. The manager of the factory needs to understand what's happening in minute detail on either a machine level or a production line level or on the factory as a whole. They need access to the information, and at the same time, the CEO or the regional director, they're looking after 10, 20, 30 factories. They don't need to know that machine A in warehouse B didn't work for 3 hours. What they need to know is, across all my warehouses, what's the failure rate of a machine? Like, how likely is it that something will be errored this week? Is there a region where it's happening more often than not? And make those kind of higher level decisions. And the CEO wants to report that kind of stuff there. But with Bacalhau, you have the same interface for both of those people. So the manager can say, I'm not interested in everything that's going on everywhere. I'm interested in what's happening in my factory, keeping all of that. And it's one CLI command that says, hey, go and make this program and get me the results and bring them back to me. The CEO or the regional director, they would do their same thing with a dashboard, but they say, hey, Bacalhau, get me all of these factories, but while you're there, figure out what's going on them, break it down for me, and bring back those aggregated results so I can have an insight. If they then want to dive down into what's happening on the factory level, perhaps the factory's productivity has dropped by 20, 30, 40% in a month. You'd be like, well, what's happened there? They say, oh, we had a big machine failure or some power lines damage. It's taken a while to get online. But it's the exact same interface, the exact same software you can use to zoom in as much as you want or pull out and get that wider view. It doesn't matter that there are hundreds or thousands of miles between you. It doesn't matter that, we recently built a distributed compute platform into a briefcase called the Football, which we did for a laugh, but also to demonstrate how adaptable Bacalhau is. Because you have a compute cluster in a thing that you can carry in a bag. But the thing that we didn't tell people very much was, it doesn't matter if I'm with the briefcase or if I'm in Australia. I can deploy workloads to it automatically, just as if I was there. Same interface, wherever you are, whatever the system that runs it. And it's such a powerful piece of technology that we really struggle to get people to understand the sheer breadth of what it can do. So that's part of the reason that we do these kind of conversations, to walk through those factory level examples, how it works with Walrus, how it can work in green energy, how it can help you deploy applications across multiple cloud platforms. Because we think that having these kind of conversations might get people to go, oh, hang on a second, that's a problem I have. Or actually, that's interesting how I solved that. How can I use that in what I'm doing here? I could use it to figure out when my toaster pops, or I can use it to figure out how to update the maps in my car's GPS system. All the things we talked about today are things that we are working on Bacalhau trying to solve. And so you're talking like drinking your own champagne, we call it dog fooding over in the UK and in the States. Eat your own dog food. So I prefer your champagne is delicious and dog food tastes awful. But so the kind of problems that we're looking to solve all the time, it's always not, it's like, how are we going to solve this with Bacalhau? And one of the crazy things is that it's so easy to set up. When it came to the distributed computing briefcase, the Football, it took 20 minutes to fire that up, to fire up a compute cluster. It then takes like another minute to add a GPU into that from AWS. And we were using that to crunch real workloads in real time in front of people on, we're at TechCrunch in San Francisco a couple of weeks ago. That's what we were showing it. Oh, we don't have enough compute capacity here? That's okay. We'll just extend it. Bacalhau enables us to grow and shrink our compute capacity as we need it. And, we use it to run edge inference. We use it to run database storage. We have a distributed DuckDB querier, which is really, really nice. So if you have DuckDB in the different places, again, it could be that each car has a DuckDB instance running inside of it there, because you can run that sort of stuff on anything.
Yeah.
It could be just monitoring engine temperature or tire pressure. If
Yeah.
the manufacturer wants to understand what's going on with their car, they can write one SQL query, which gets distributed to every car on the network over Bacalhau.
Yeah.
All those results processed locally, so you're not doing a million queries, you're doing one query on one system. So it takes no time at all. But then you're bringing them all back, and you can say, okay, I now have the actual, like, what's going on for the things I'm interested in, not just a whole data dump of, potentially terabytes, petabytes of data. You've got the insight, you've got the knowledge now, and that's what you can use to go and make decisions. So
Yeah.
we love applying Bacalhau to those kind of problems, because it's so expansive in the data tool, hence expansive.
Yeah, it is. Yeah, so tell me a bit about the name. Why is it? Because it's expansive, it's all the way around. Name journey of Expanso, how it was started, how it scaled, how the product life cycle happened, how do you folks and your team goes around talking to people about and evangelizing the journey. But what's the story of Expanso? We know now a bit about the entire tech backbone of Bacalhau and others. Tell us a bit about Expanso and why the name.
So Bacalhau, the software, was originally created inside of Protocol Labs, which I'm sure you've heard of previously. And they wanted to, we thought it'd be an interesting thing to kind of spin out. So Expanso created it, started there, because we saw how applicable it is to so many problems.
Yeah.
And that was about 2 years ago. I joined Expanso about 8 months ago now. Again, my job is to help people understand what it can do, and to help Expanso, importantly, understand what people want from Bacalhau. But we spun out. We got our seed round of funding. We started deploying workloads across our.
What is the vision? What is the vision that founders had? And because always a seed funding and Series A, Series B, before you go to IPO, it's about understanding if something can scale. There is a podcast called Master of Scale, and they talk about, of course, startups in the Valley. And of course, there's a Station F in France, which is known as a very large accelerator where 100 startups working, and they try to scale 10x. So what is that 10x vision that Expanso has, that you see it can trigger large enterprises to have faith, because there are big 600-pound gorillas, 3-letter gorillas, like 2 of them you have worked for, like IBM or AWS, who can spend billions of dollars onto all the Salesforce and marketing and DevRel. So understanding what niche, how you can hit that with so much precision, so that you have this so much energy. It's like being in a NASA rocket. You only have limited energy. How you achieve your target and you come back. You can't do everything. You have to conserve energy and do. So what is the 10x vision, and how do you? I think you got
get there. Yeah. So for us, it's very much about enabling secure computing anywhere.
That's amazing.
So all data, all systems are accessible but secure. You can extract those insights no matter where they are. Again, that comes back to the compute over data. Right? There isn't much. Everyone thinks about having centralized places to centralize software, centralized data, crunched all on one big machine. That's not the way we see it. We want to move compute away from these central hubs, and we want to move to where it needs to be used. It's kind of bonkers that we have these big, powerful computers that we're feeding everything into. We actually have way more less powerful but still completely able computers with data at the edge that we aren't using to crunch things. So for us, it's about maximizing the utility of all compute everywhere in a secure, repeatable, unified way.
So so you are moving compute to the sources of data. You are at the horse's mouth. You are feeding exactly where the need is. So the rise of edge computing started at least a decade back. With the word itself came compute, edge computing, cloud computing. Edge computing started with Intel and their SGX and their cloud, and that's how the Intel grew its journey. I remember, and now I'm sounding a bit dated because IBM used to have Smarter Planet campaign,
I remember that. Yeah.
and a nice logo and all the dots coming around it. And that's where Intel and IBM used to work very closely together for the smarter cities, understanding the entire sensors for cities, traffic management, pollution management, entire smart city concept of having an open data portal where you can have the entire city's department, from sewerage to water to, I don't know, all the waste management to everything. You can electricity, utilities, everything, feeding data together, and then the mayor of a town or the city council taking decisions whether it's a road which has fallen after the wind, getting that cleared, getting power restored, getting food delivered, schools functioning, everything. That smart city concept itself was built on cloud computing and edge computing and bringing compute to the edge. So tell us a bit, because when you were mentioning about taking compute back to the edge, because it helps. One is definitely it gives you governance. Of course, if an organization wants all the data to be with them for any auditing purpose, they can always get 100 petabyte back, because audit happens once in a year. It doesn't happen 365 days. The auditor will come one day. They want everything, and they will go to a couple of plants, and then they're happy. Okay, we are good. They will see the compliance sheet. They will see the risk controls being monitored. There's no violations. There's no security incidents happening. So tell us a bit about when these city councils, these large governments, when they want to have an affordable solution. Because we have heard of stories of NHS being hacked, we have heard the story of hospitals being hacked, ransomware, a lot of patient data. It's so much, it kind of agonizes me to think that what do these people get by harming these helpless people.
Yeah,
so it puts a bit of mission in my mind. I'm not trying to preach to the... I'm just being honest with you.
Yeah. So healthcare is a really good example, actually. Like, our personal health data is perhaps some of the most private and yet incredibly relevant information to ourselves, which is why its security is absolute paramount. It is the number one concern. It must remain secure. It can't be left on a disk drive on a train. It can't be someone walks in, just flicks through a file folder or downloads a file. It can't be on the internet. Right? But we still need to be able to access that data. The NHS still needs to be able to access data to treat patients effectively. Researchers still need to be able to access that data to see, what's happening with, the society as a whole, and understand and build treatments and tools help them to do it. How do you do that without making it less secure? Because again, there's no like lever you can pull to that's okay for private medical data to be secure, not secure. It is secure. It is iron cast. It is solid. It has to be secure. That's the promise there, right? But you still need to be able to access it. You still need to be able to do things with it. You still need to be able to utilize it so that people are well, so that they are safe, so that they are healthy. And that's where something like Bacalhau comes in. Right? Data can be kept secure in a place with encryption, with the right, having a lock on a door, making sure no one has access to the security cabinet, right? Making sure it doesn't leave a burden, make sure it doesn't leave a border. But how do you have medical professionals help you with that? Take an example we had recently. We had a research team at a United States university who wanted to try out a new vision model for diagnosing cancer in patients. But the data set they wanted to use to test it against was in the Netherlands. And these are real scans. These are people who have scans who did not have cancer. You cannot take that data out of the Netherlands. It is not allowed. It's never going to happen. But those people will benefit from this model being able to run on it, to understand what's going on there, so that there can be early diagnoses, so that it can be dealt with before it's a real problem. It can be nipped in the bud, as it were. So how do you connect those two groups without compromising the data? Right? You leave the data where it is. You leave it safe where it is. But you enable the research team to send over their application, compute in that space, and egress anonymized insights, not data, the insights. So they were able to package up. So
Sure.
What the researchers were able to do was containerize this model inside, in a container, ship that to where the medical data was inside the Netherlands, keeping it in place, keeping it safe, keep it secure, run the model over it. And only that's one thing that Bacalhau does allow. You can say, actually, this application can only read data in this place. It doesn't have access to the whole system. It has access to the directory where that test data has been set up. Right? can run its inside over it, and then egress the results. So not the data, nothing private, literally just did it work or did it not? It comes back to it. The benefit there as well to the researchers is that their models stay secure. This is a valuable, useful piece of technology that's being built by university. They don't want, people somewhere else to be able to pull it apart and tear it apart. So it's safe inside the container. It's able to move and execute, and we all benefit from having this now better model and being run on real data, but in a secure, safe, repeatable way. And nothing's left anywhere. It's also really expensive to move a team of researchers from the United States to the Netherlands. You don't want to do that. So they can do it every day. They can keep testing it. So innovation happens quicker. It's cheaper. It's faster. It's more secure. So no centralization. It's a beautiful example. So we absolutely love talking about that one because really good stuff's come from it. And it's not something that you could do with more traditional architectures or ecosystems. And again, like another example of this is financial data. Again, incredibly personal, but incredibly useful to understand personal spendings, trends in economies. That information is not something you want out in the world. But banks need to be able to process it to understand what's going on with their customers. Insurance companies find it useful to be able to see what's going on there. And there have been movements made in that direction. Open banking, for example, a person can opt to enable people to have shared data in the UK and across the EU. Open finance is another thing like that. But with Bacalhau, you can keep that information on premises in the bank. You and I, again, we've worked for Big Blue. We know how much of the banking sector and the financial sector have data in-house and compute in-house, how they service that. But those are very old systems a lot of the time, and they're very inaccessible systems. By having Bacalhau on there, you have a simplified way to be able to access that data, crunch your calculations, anonymize whatever you want to do, and bring back that aggregate result, all without ever leaving the building. So, when it comes to data security, on-prem, at the edge, in the clouds, that is the kind of vision for Expanso with Bacalhau. We want to make compute as secure and as fast and as efficient as possible.
That
no matter where it is.
BFSI, banking and financial sector, you come from FTSE and Financial Times, and FTSE itself is a large powerhouse in financial network, next after Thomson Reuters, and of course there is Bloomberg and others. So people know that when you talk about trading, the ticker data itself is like hundreds of millions of ticks per second across all the scripts. And itself is a good example of data being processed, and all the brokers which do real-time stock trading, who do volatility analysis, all the indices, there's a lot of compute happens, and they just keep waiting. I remember Goldman Sachs had put in a special optical fiber cable from Chicago to New York just to reduce latency, so that they can trade a bit faster, so they'll get the options.
But it's the edge, right? Absolutely. Yeah, it's getting that extra little bit.
Yeah, even if you make 0.01% improvement because your size is $1 billion, you're making at least $10,000 per trade better. That itself becomes 100 million extra per month. It's a huge number. And I was thinking, why would they put their dedicated? I remember when I was in IBM, I remember someone coming and telling me it was for a stock exchange that can we put a dedicated fiber? I said, why would you want to put a dedicated fiber? Then someone came and explained the logic. I said, wow, that's minting money. They're just putting a dedicated cable from IBM Z mainframe to their trading panel. They want to reduce that 10-second lag. Oh man, they said because they had VPN, they had like all the Fortinet gateways and the firewalls, and so they
and you're routing it. Yeah, people forget that when you're on the internet, you're not necessarily getting the most direct route between things. I'm calling you right now, and you're in Mumbai, I'm in Wales. So you might think it's a straight line, but I could be bouncing between 20 different countries and going back and forth just to have this connection happen. We could be talking right now via California. It's going through Google, and so it's going, twice the distance around the other side of the planet. When it so having those direct connections, having that means to say, I need it to be in this way. Those efficiencies, they might seem like very small, but on the scale of global productivity, global commerce, global data generation, it's magnitudes of value being lost to inefficiencies, right? And that's something that we spend a lot of time thinking about. One of the for the tech inclined readers, listeners you have, we use a protocol called NATS. That's NATS, which is an incredibly efficient and fast pub/sub messaging protocol. So it's practically a layer above IoT, above TCP/IP. It's
Mhm.
incredibly fast. It enables us to push a lot of data down the wire in super fast times, because we could use something like MQTT, which is
Yeah.
phenomenal piece of software. I love MQTT, but the latency you tend to get when it's processed everything is maybe 100, 200 milliseconds, which for the average Joe is something that is very, very fast. It's faster than the blink of an eye. But if we can do it in 10 milliseconds, we can do 20 times as much as you can with our NAT system versus MQTT. That's another piece of open source software. Again, we stand on the shoulders of giants, but check out NATS. And again, it's where we're trying to build in as much efficiency as we possibly can from the ground up.
So it gives me 3 examples. NATS is a messaging system designed for high performance cloud native event driven applications, and the clients are Etsy. Etsy uses NATS to support the real time services and microservice architecture. Second client is Citibank. Citibank uses NATS for its trading systems. Exactly what we are mentioning.
Unsurprising. Yeah, there we go.
Citi uses NATS for its trading system to achieve low latency messaging and event driven data processing. And the third one is a very popular IDE that I got to know, a company called JetBrains. A lot of people don't know JetBrains, but JetBrains make amazing IDE. People, old timers still use VS Code, and even before, people use their own favorite Atom and other IDEs.
That's
but
right.
JetBrains, yeah, I know, I can see a smile coming in, and they are like tabs and spaces is a separate fire burning, but then Atom and VS Code, and there are other fights happening on the other side. So JetBrains uses NATS. JetBrains uses NATS for scaling microservices communication and ensuring real-time event processing. And the benefits is low latency because
incredibly low latency. Like it's super low tech stack. Yeah.
And scalability, it can scale horizontally, horizontal scaling compared to vertical scaling to millions of connected clients. So it doesn't reduce the time it takes for it doesn't do daisy chaining, it doesn't do polling. So if you poll across multiple clients, your number is not ever going to come.
It's incredibly efficient piece of software. And again, we introduced it.
Yeah, and a lot of people don't know the concept of daisy chaining. If I tell them what is daisy chain, they look at me like, are you talking about Mickey Mouse? I said, no, that's not that daisy. Daisy chaining or polling is when you go to all the devices one by one, you hit them, again the time comes. Sorry, you were saying something. Sorry.
No, I'm completely agreeing with you. It's one of those things that, again, we're trying to challenge how people think about that. If people say, I have 1,000 computers, I need to understand what's going on in each of them. Think about it. Let's break it down. Let's say there are 10 computers, right? If you wanted to get information from 10 people, what would you do? You'd walk up to them, you'd go, hey, what's going on here? And they'd go, this happened. And you go to the second one, and then you go to the third one, and eventually you'd know what's going on, right? Whereas it's unnatural for you to stand in a room with 10 people, shout out a question, and have them all
answer. How is everyone doing? How are you doing? You're all doing good.
But if they're all doing great, it's fine. But if they all have a different answer, it's really hard for us to pick it out. But
for everyone.
This is the thing, for a computer, it's really easy to do these things simultaneously. So, whilst we think about how we interact with computers, a lot of the way we interact with each other, mapping that to a different model, saying actually computers are really good at parallelized processes. So rather than daisy chaining and saying, hey, we're doing a round robin of all the different servers, you can say to all of them simultaneously, hey, what's going on? And it can all report back, and it happens in the flash of an eye. It's incredibly fast. So one of the things we're trying to do is challenge the way that people think about how we design these infrastructures. It makes sense to want to centralize things because it's all in one place and you can keep it all in your head, right? But it's actually better to have things across the edge and let the network and the system do what it does best, which is manage data dynamically in different places and get the work that's the way. That's the most logical thing. Do the computing on the data where it is. Don't bring it all in. You're not the computer. You don't have to process these things. You have a bunch of machines that can do it for you way more effectively, way more efficiently on the edge. And so it's one of those things that we had to spend a lot of time talking to people about. That's why I'm here today, to get people to think about it. But when people get it, when that light bulb goes on, when that flip switches in their head, they're like, oh, and then they never want to do it another way. It's the way they want to do things now. And it's incredibly satisfying to see people go, why weren't we doing this all along? That's the beauty of it right there. So we love those kind of conversations.
And that this decentralization actually helps people to get to insights faster because a lot of people, a concept has been beaten hard into the minds of people. It has been drilled down that first to create a database, then you create a data lake, Then
Mhm.
you done an ETL, you have like Hadoop and Cloudera and others.
Mhm.
Then you have Apache and Hive and Pig and others. Then you
Mhm.
run ETL on top of that. Then you make pipelines. Then you make
Mhm.
dashboards. And then something like Click comes, or Tableau comes, or
Mhm.
some other they come, and then you get to an insights. No, you don't need to get a data lake to get an insight. You
No, you
just need to
don't.
know what's happening. The people get so scared of a data lake. They say they get those are stuff for by big tech to sell a lot of stuff.
But this is the thing, like, again, one of our most successful blogs we've ever written was about how to create a data lake without creating a data lake. How to how to treat all of those different nodes as they are a whole. And it's the
Yeah,
sort of thing that Backyard makes really, really easy. I've
yeah,
built data lakes in the past. I've built huge
yeah,
data lakes for companies.
yeah,
And sure, it did make things easier, but it took me 2 months to build it. It was really expensive to run, and no one could actually query data in the end. It was so hard to get information out of it. It was nice to know it's secure, but getting the value back out, getting the insights back out was super, super tough. Right?
yeah,
But now I can literally, with Backyard, write down the SQL command and say, go to all these different places, run that query, get the results, aggregate, bring them back. So
yeah,
my data lake is every computer I already have. There is no
yeah,
extra system. It's the control plane. It's the interface for it. It's
yeah.
ephemeral. It's ethereal. But you get the same sort of insights as you would to having spent time and money and blood, sweat, and tears getting
Exactly.
things in one place. You don't have to do it anymore. You can
Yeah.
just utilize what you've already got. That's the fun part. And
The
again, we love it.
the time and money and blood and tears and sweat and whatever that becomes such a big, there's a term called
Mhm,
technology debt or tech debt, technical debt.
mhm.
That technical debt is so
And
big that people
so
are
hard to
so,
migrate and move
yeah,
afterwards. So hard
they're
to
so
change.
invested. I have spent
Yeah.
hours away from my little child working on this. I will not let this fail. I will go to the end of this earth till to make it work, because I am so deeply no, sir, it's just tech debt speaking.
This is the
Just
thing.
let
And
go of the past and move on for a beautiful future.
listen, when people have those kind of systems, they comport themselves into something that isn't quite what they want or actually need because it's there. So they go, okay, we
Yeah,
can kind of make this work. We can kind of figure this better over here. Because it is this one huge application, it's so hard to change these little things to make them incrementally better. Right? Whereas
yeah.
I could have 1,000 computers with 1,000 databases on them. I can run one command and I can have all those updates simultaneously.
Yeah, and
Yeah.
because historical data, to be honest, see, there's a concept in computer science and physics called and advanced maths called Markovian. The
Mhm.
Markovian processes are those processes which are only dependent on the current stage. They
Mhm.
are not dependent on the historical data. So if I
Mhm.
say a process X is Markovian, so and if I write in a mathematic format, so X t plus one is dependent on X of t. That's it.
Mhm.
Nothing of xt minus 1, nothing before that. What
Yeah.
is, so you will be tomorrow what you are today. That's it. Nothing, your past doesn't matter. It's a bit like meritocratic culture of America,
This is the
that
thing. It just
where you come
advances
from
forward.
doesn't
There's one
matter.
direction of travel, right? Yeah.
Yeah, where you are, that will define your future. All your baggage doesn't matter. It gives you equal opportunity to everyone. It's kind of that kind of culture. What that also helps to understand, you don't need such data lake, because those historical trends are not going to repeat. So if you
Mm.
are in a trend hypermarket, you are trying to say in past 50 years Brits have been buying this kind of t-shirts, or in bank the people who do this kind of transaction will buy this credit card or this
Mhm.
home loan or this mortgage. No, a Dua Lipa album comes next, and they will be buying some other T-shirts or some other clothes. If a Santander Bank launches something, or if suppose JP Morgan launches something, they will be buying different kind of mortgages. So that, because that historical data is good. So now
Mm.
what I have found is that they have spent like so much amount of money in all those cloud
Mm.
S3 devices on IBM
Mhm.
tapes and devices. Now these senior CIOs, they need to justify that you
Mhm.
have kept this 70-year-old data and you are still keeping it. So what, you are spending money, now you tell what you're doing with it. And I
Yeah.
tell them, sir, this simple logistic regression doesn't need 70-year-old data, because that person is dead long, is buried 6 feet under the ground. That person is not buying. This new Gen Zs don't even know me. When they
The
see me,
mainframe
they
is,
think
yeah.
I'm a weird Gen Y or Gen X. They are Gen Zs. They don't. So those data, with those data points that you have, all due respect, you can keep for say next past 5 years or 10 years, 50 years. because why I say this, because you talked about BFSI. I've been part of the IBM's travel and transportation industry as well. The travel and transportation industry is another oldest user of technology. 1950s, they would have purchased a time-sharing IBM mainframe, and American Airlines would have bought it in 1950s. They would have been, because they need it, right? I need to know if there's a ticket available or not. I want to know if I can book a flight from Chicago to London or Chicago to New York or not. So you need to have some way. You can have a lady on a telephone, but you still need a computer.
And you still need that data store somewhere.
So airlines are the airlines and the banks. They are the oldest users of computers, and trains maybe. So trains, because airlines need to have million people, they need to know tickets and seats. They cannot have 300 people plane and 500 people booked. So they needed computer. They didn't have website those days, but that's fine. So airlines, banks, and bit of trains. Amtrak trains in the US and others. They still use.
Absolutely.
They still use the older floppy disk system that was in the Financial Times, and the Thomson Reuters also reported that they have to put in all the IBM system, and COBOL boots up, and suddenly the train starts running. They get
COBOL will never die. COBOL will run till the heat death of the universe. Like it is, it's so foundational in those things. But again, with Bacalhau, you can deploy modern COBOL to any system and just augment.
Exactly. That's
what I need to change anything.
Yeah, that was what I was coming to, because so we talked about the cloud native technologies, we talked about edge computing, we talked about NATs, the underlying technology. So cloud technology and cloud native and edge computing, then the backbone NATs. We also talked a bit about Kubernetes and how others have helped in the process, agile and security and stuff, and how Expanso changes. We also talked a bit about the IoT platforms and how it differentiates about bringing decision making to the edge. We took a couple of examples. We took the example of a bank. We took the example of a manufacturing plant. We also took the example of healthcare. A lot of people also would want to know that what is the technology adoption, say, future, when they want to grow on Expanso, when they start to deploy Expanso, when they want to have a hackathon, they want to play around with Expanso, because it's there. People can download that file. It's there. I saw it's there on the website. People want to set up a playground, set up, say, some CRM data. A lot of banks, of course, there are some who use Salesforce and other CRM, so a lot of data is there. But a lot of transactional level data or log monitoring data, log data is still there. And these logs data could be in both IT systems, like the network operating center, the NOCs and SOCs. So NOC will have all the network monitoring logs coming in. So they want to know. So if a superstar takes my name, hey, Naval, I just heard of a dude called Naval. I'm just kind of manifesting.
Time.
I'm manifesting. So if Bruce Springsteen says, "Hey, Naval is an awesome guy," go check his website. Or if Bruce Springsteen says, "Sean is an awesome guy," suddenly SMT.codes sees a million hit. So if a million traffic hits SMT.codes, is it a DDoS attack? Or suppose you had put like a 1 cent fee, for example, for something. For example. You have an app and it has a 1 cent or a 1 penny or whatever. And a million or 100 million people hit SMT.codes. So that means you are making £1 million immediately if you have a payment gateway. That payment gateway shouldn't shut down, thinking that those 100 million people over a weekend are a DDoS attack or a nation state attacking you. It's just because you will later go and see someone mentioned you on LinkedIn or a Twitter.
One certainly hopes, yes.
We try to manifest nice things and push them into the universe, and they might come.
They should definitely check out the Expanso website, which is expanso.io.
The websites are the websites are the show notes. Why I'm saying this is because these logs and these need to be gathered. If you can analyze this, then the website will not go offline. That analytics needs to happen immediately.
Absolutely.
It's instantaneous analysis. So it's not a security event. It's not a network event. It's normal thing. It's people coming from different parts of the world. They like this dude. They want to check this website out. Another example, if I remember, is Pokemon Go. I was in a Google conference, and I remember it's 8 years ago, and they had plot a chart, a parabolic chart, and they had put like one line and a horizontal line, another horizontal line, a third horizontal line. So I was representing IBM in Bangalore. There was some event there. So they asked me. It was an open source event, and I think they were presenting Project Borg, the Kubernetes. It was those days. So
Yeah.
they said that this curve cuts all these horizontal lines. You know what the first cut is, and they have dropped a perpendicular from there, and there. He said, we don't know. We are playing along with them. They said that's the capacity that Pokemon Go and the Niantic had reserved for 7 days in cloud. Okay.
Crikey.
Then they said, you know what the second line that this parabola cuts? That's the capacity they had reserved for 1 year. And the third line it cuts is the capacity they had reserved for 99 years, which is the upper part. Then they dropped the horizontal part. They said, how long do you think it took for them to consume their 7-day capacity? And we were like playing around. They said,
20 minutes.
They said 13 seconds.
Good Lord. Okay, that is impressive. Wow.
They must have done some amazing pre-marketing, like pre-launch stuff, and they would have put some logo and stuff, or they might have reserved something very less, because a lot of games come and go, and nobody picks up a phone and tries to look for Pokemon, right?
No,
nobody
never underestimate the power of Pokemon. People do love Pokemon.
But they didn't know, right? They can't be prescient. They can't be prescient to know that I'll make something that, just like you were mentioning, nobody suddenly SMT.codes will not hit. I didn't want to use the word expanso.
No, it's fine. It's good, yeah.
Because as a human being, someone will say, then you will get worried. Why are people? Why is the website getting so many hits? Is something wrong with it, right? Or is there a malicious server putting in so many hits? Because that's the data being generated, right? All the logs are coming in. So Pokemon Go is a classic example. So Google didn't turn it off. If Google would have thought it's some random dude make a random game called Pokemon, not very well-known company, and it's a runaway hit. And then they asked, how long do you think it took them to, and it's a weekend. The game was launched on a Friday night. And how long do you think they asked us it took to consume 1 year capacity? And that was like 4 minutes. And 99-year capacity was used by Monday. So Monday morning, sales rep had to call, sir, your 99-year capacity has been used. This is the history of Google runaway success. We are not going to turn it off. It will keep on scaling, but you may need to have a look at the contract or whatever. So 99-year capacity in 3 days. And
that's impressive.
And why I mentioned this as something that happened to me in a large auditorium so many years ago, because that presentation stayed with me. That simple chat. Then they did all the demos and boring stuff, and that I know I can go on YouTube and see. You remember at the beginning of the podcast, I talked about that if I show a demo, people can look for a demo on YouTube. They want to know who you are. They want to know what how is. They want to know what Expanso is. When humans get in touch with humans, they want to know. Then that's where the curiosity, the fascination happens. When people get fascinated, that's where they go and play around, because you can't pay them to go. If Apple sits at $300 billion cash, people still use MS Excel. Apple still couldn't make pages and numbers and keynote so popular. Why not? If you give me $100 to use pages, I will not use it. I'll still use MS Excel, because my teacher didn't teach me spreadsheet. She taught me Excel. She didn't. A lot of school teachers, they teach MS Excel. They don't teach spreadsheet. They don't teach word processing. They teach MS Word, because open source isn't there. Open source isn't popular enough. If open source had been popular in the school, now it is becoming popular. Those days, those were the days of WordStar. WordStar and
WordStar, yeah.
So you would write WS and press enter, right?
Yeah, that's it. Yeah.
So
gosh, yeah.
For me, word processing is WordStar. For me, Excel is Microsoft Excel 95, 97 is spreadsheet.
95, 97, yeah, I remember that.
Yeah, remember that? I know, I could see a smile come. I could see your face lighting up, because all those memories come flooding back in. That nostalgia keeps flooding back in. Why I'm mentioning this is because once there's that connect happening, then people will go and play around, and then 20 years later, I still use that, and I will never use numbers and pages and Keynote ever. In the same way, Pokemon Go didn't pay someone to go, and it's just people took fascination to it. It became a runaway hit, and nobody can. People now try to match it, and they do all
very
the
hard
and stuff. It's about people making stuff that is fun and putting it out there on a cloud service, which is as you folks are. Or as, if you want to take me in, then as we folks are, then which is scalable, across millions of devices, uses NAT. So if an opportunity knocks your door,
Mm.
you actually go and get the bloody door open. You don't
with that
sit
in mind,
behind.
with that in mind, we are just about to launch something that is fun but uses Bacalhau. We've just
Yes.
about to launch a Blue Sky bot. So
Man.
right now, like if you want to run a Bacalhau job, you do it with a CLI. Right?
Yeah.
But as of next week, when we put this out there, you'll be able to use a Blue Sky
Dear
post.
listeners, that's exclusive. We haven't paid Sean enough to get us those exclusives, but this appeared first here.
Yes. First time. So it'll be going out tomorrow, hopefully. Basically, you'll be able to message the Bacalhau bot with a Bacalhau command, and it will get distributed to a compute network across the world to do your workloads automatically, and it will tweet you back the responses. So you'll be able to run distributed compute workloads with a Blue Sky app. You can do it from your phone. And we don't think people are going to run huge or business critical applications, right? But we think it's fun for people to see that you can do these things really extensively, expansively.
Yeah.
And that's kind of at the core is like what I want to do at Devon. I want to show people how simple and how widespread this stuff can be, how easy it is to get started,
Yeah.
And I think that kind of stuff there, it might be on the surface level, like not the most important thing, but it is important to engage people. It is important to challenge how people think about how we do these things. People don't think about running Kubernetes jobs through Twitter, right? But you can build that system, and if you can build that system, you can build any other kind of system with it too.
Yeah.
All you need is a little bit of networking and a little bit of Bacalhau and a little bit of code, and it's wonderful.
Yeah.
And just on that note, Naval, we should probably wrap it up because I have to go.
Yes,
in a few
that's
minutes,
what I wanted to tell because I didn't want we're 3 minutes over. I didn't want to stretch it beyond, but I'll be cutting these parts off.
Of course, all good. Yeah,
can I take a couple of minutes, just maybe 2-3 minutes, because there were a couple of interruptions. I just want to ensure that this
Absolutely,
part.
No worries. Let's do it.
I'll try to wrap up. It's 8:33 here, so it's maybe in next 3 minutes at max.
Yeah, sure. All good.
This is one question maybe, and so you have seen, both of us have seen. We have worked in Big Blue, which is like the grand old man of computers, invented computers, meat slicer and whatever, and then the evolution of compute to have calculators, to mainframe computers, to Z systems, power systems. Then a little guy called Google came into picture, late 90s, early 2000. That's where the cloud computing was born. You were fortunate enough to be a part of the cloud computing behemoth AWS as well. That's where a bookseller who had a background. I guess the beginning of AWS, which is part of the Harvard Business School case study, is that whenever there was a Black Friday sale, Black Friday sale, the technology systems crashed. So Jeff Bezos told them that make a system that survives a Black Friday sale. It's like you put your IT systems. It's like if IBM has a great IT department, why don't we put it out as a service and sell it as services to people and make all the departments as instead of them being a cost center, let them become a revenue center, make them as a shared services and let them earn money from outside as well. So they have just outsourced the IT department and then call them AWS. Something similar was done by an airline company in Singapore as well. They had such an amazing IT department that they productized the IT department, and now their product is used by all the airlines across the world. So if you're doing amazing stuff, you can then convert your IT team into a product management team and then make a product and then put it out. That's how the AWS was born. So you have been fortunate enough to see the mainframe, the cloud. Now you have worked across large organizations now with distributed computing. Cloud is going even nearer to data and data source of data and data generation, so that the data doesn't come. You figure out where the latency comes. One is the sensors that gather data. Could be humidity sensor, temperature sensor, vibration sensor, all the sensors. Or laptop, Dell has their own sensors in manufacturing plant when they manufacture rotating hard disks, whatever. So whenever you are moving decision making closer to the edge, Intel did that a couple of decades ago. Then they brought the smart cities part there. We talked a bit about Honeywell, Siemens, and large organizations who would do that as well. We talked about multiple industries. You have seen that entire evolution comes across. Of course, I'm not saying you are 170-year-old, but you are just 165. But what do you see the future? Because what I remember in IBM is the dream big and you big bets. IBM used to take a big bet of next 100 years. I know it's not easy for human to take a bet. They're like a lot of McKinsey consultants and McKinsey and BCG and Bain and do a lot of analysis, and then they talk about. But next, say, couple of years, maybe 2 3 years, what do you see that will help Expanso or Bacalhau become very relevant and become a runaway hit if you were to manifest such success of Pokemon Go for this? Because humans can't make Pokemon Go success. If there is a human dependent thing, it cannot be done. But humans can use it, but humans can't scale it. Sorry, please go ahead.
No. So let's focus on the 100-year bet. What do I think will be true 100 years from now?
Sure.
Because everyone I know will likely not be around 100 years from now, right? But if this is written down, if this is carved in stone, if someone were to go back and find it and read it and go, oh, Sean was right, what would I be willing to bet? And I would be willing to bet that 100 years from now, people won't think of a computer as a thing, as a box or a server or a phone. Computers will be so homogeneous and so, well, not homogeneous, but so readily available and so interconnected and so standardized across the interface that people won't think of computers. They'll think of the computer, the planet-wide computer. And we have the echoes of that now, the shadow of that now, with things like AWS and Azure and GCP, these competing ideas of what is the cloud, the competing sections of what it is, but they aren't interoperable. They've all got their own ideas about how things work. I think eventually those will converge. I think eventually those will converge through something like Bacalhau. I think that when people want to run a program, they won't think about, how do I get this on my computer? They'll just make it happen. So that's my bet. My bet will be that computing will be so ubiquitous. And it already is pretty ubiquitous, but the way in which we interact with them will be so ubiquitous and standardized and deployed. You won't think about, the individual computer. You'll think about it as the whole, So rather than having to go, which part of the cloud do I want to run this in, or what kind of system do I want to run this in, you just say, I want this to run in the computer in this kind of place. And whether that's, whatever AWS or GCP or Azure becomes, whatever replaces them. Because as we know, nothing is forever. Whatever that looks like. I think that's my 100-year bet. My 100-year bet is that everything will be integrated, that everything will be standardized, that there'll be some competing ideas how it works, and there'll be some logistical challenges there about what shape it takes, but that something like Bacalhau will be at the core of that. God willing, Bacalhau will be at the core of that. That's the revolution we're trying to bring. We're trying to bring an abstract layer of compute that doesn't matter where it is, what you want to do, how you want to do it, that it just happens there. You don't think about the cloud, you don't think about the computer, you just run Bacalhau. Bacalhau figures it out for you. That's my bet.
On that note, ladies and gentlemen, boys and girls, I will, let's say, I want this to happen, to be completely honest. And I believe that in the future, your Fitbit will not just gather your data, it will also tell you what food you can eat. You don't need to go to cloud to get a recipe made. If the data is there,
on device.
The device knows you better. There are neural link coming in. The computer is coming to your own. They have glasses. They can gather data. A lot of stuff. You don't need to go to server to get some analysis. If you want to know what food you can eat or what diabetes level, what blood sugar level you have, you already have those devices with you. You already have. So you can take decisions, and that can improve the quality of life that you lead as a person. As organizations, that can improve the quality of decision making. Of course, Google and others and sensors and technology have made data driven decision making very popular. That we used to take a lot of decisions based out of gut, and that I feel that this might be true. That has paved way to take that data says something else. That's now when that decision making happens on fresh and raw and quickly available data. And when there is governance on the sensor to know that the data is true, there's fidelity in data, and the responses are prompt, in time, accurate, trustworthy, then that will significantly improve the quality of decision making. It will help live a better quality of life. It will help lead organizations take better decisions, better productivity, and better output. Thank you so much. I just can't thank Sean enough for the entire journey of one small kid in a classroom where a teacher rolled in a box, and that boy or that kid has come so far. and has made so many lives different. It's like a candle lighting another candle and just passing the flame along. That's the spirit. It's like one candle at a time, but there's always that holy candles, kindred spirit that helps someone grow.
So long as you don't set the world on fire, you got to be careful.
As you don't set that, I saw that part as well. That sometimes I write JavaScript that sometimes set fire, but not intentionally. That's where I know. So that Sean knows that I do my research well. So I've seen all. So I know exactly where it's coming from, which JavaScripts and which servers he sets fires on. We'll talk that on the next podcast, maybe in the future when we're able to get some time. But definitely, we must thank Sean for the time that he had and a couple of extra minutes that he graciously offered to give to us from his very busy schedule on a Sunday afternoon, where he has to go and talk about tech to different people and make tech friendly, and that's where humans resonate with humans. And we wish Sean all success. We would love to see him grow and become an amazing tech leader in the future. Not that he is not today, but lead tech and adoption. And lead tech adoption help humans take a better decision with their life. Thank you so much, Sean. Any parting words? Any pitches that
friends. Always a pleasure to be here. Thank you for your time. I really hope that people enjoyed listening to us talk. I've certainly enjoyed it. If anyone wants to ever have questions about distributed computing or Battle Royale, I'm on all the social networks. Please do reach out. Naval knows how to get me as well, so reach out to him. Naval, please do forward people to me. And until the next time, I hope there's next time. I'm sure there will be. I very much look forward to speaking with you again.
Thank you.